This presentation is delivered by the Stanford Center for Professional Development.
What? A lot of, no, not Lancelot. I almost considered Carol. I almost went for Carol. I get the big box, but it's kind of hard to draw. It's sort of like, Carol cannot draw all that much in the big box. No? Well, I'll give you hints as we kind of go along. And at the very end, I'll show you if you can't figure it out. I almost considered giving whoever could figure it out 100 on the midterm, but I figured that was kind of just a superfluous way of giving you 100 on the midterm. So I'll just give you lots of candy. So anyway, just think about it. And if you want to try to search the web or whatever, it is a one particular character. And it's not a wizard. I actually thought, oh, I could just make it easy for you and just come in and be like, ha ha ha, because most of the people who like, you know, without the hat would see it, they'd go, oh, you're a wizard, right? No. So I just brought the hat to kind of fool you. All right, so with that said, time to actually wrap up one of our last topics, which was arrays. We'll look at a few more advanced things we can do with arrays, and then get into the details of our next great topic, which is our friend, the array list. Okay? So when we talked about arrays, a couple of people last time said, hey, Meron, can I have like multi-dimensional arrays? Can I have arrays that have more than one index? And in fact, you can. We do refer to these things as multi-dimensional arrays. And just so one way you might want to do it is, let's say you wanted to have, this dreaded thing called a matrix. How many people know what a matrix is? I'm not talking about the bad movie. It was a good movie. The sequel's not so great. It's basically just a grid of information. It's a grid mostly of numbers if you want to think of it in the mathematical sense. But really, we think of this thing as a two-dimensional array. And so the way you can think about it is if I have a matrix that's a 2 by 3 matrix, what that means is it's a grid that has 2 rows and 3 columns. Okay? And you might look at that and you say, hey, that looks almost like an array. It looks like 2 arrays stacked on top of each other. And in fact, you would be correct. If we have multi-dimensional arrays, what we're actually creating are arrays of arrays. So really what we want to do here, if we want to create this thing called a matrix, is we specify the type that we're going to store in all of the boxes in that grid. And then we specify as many pairs of square brackets as we have dimensions of that thing. So if we have 2 dimensions here, like we have rows and columns, then we specify 2 open and closed brackets in a row. If we had 3, like we wanted to make like a little thing that represented a cube, we'd have 3 sets of brackets. So here I'm just having 2 because I'm just going to show you 2D arrays, and you can think about the generalization from there. And then we give it a name, so we might call this thing a matrix. And then we specify basically the creation of that matrix in the same way we created an array, except now we have more than one dimension. So here we say new. We specify the type again, like int. And then to give it the size, rather than just having one size that we specify, we have a size for every dimension. So if this thing's going to be 2 by 3, we specify the first dimension as 2, and then the second dimension as 3. And each one of these is its own pair of square brackets. We don't use comma notation. So if you've worked with some other language where you say like 2 comma 3, doesn't work in Java. It's 2 in brackets, then 3 in brackets, no spaces immediately after it. And so what this does when you create that is it sort of creates this thing that's this grid that's a 2 by 3 grid. And now you can refer to the individual elements of that grid. So the way you can think about it is this is element 0, 0. Or really you want to think of them in brackets. And then this becomes element 0, 1, and this is element 0, 2, and so forth. So this is element 1, 0, and this is 1, 1, and this is 1, 2. So if you kind of think about assigning elements of that, you could say something like matrix 0, 1 equals 5. And what that'll do is they'll say, oh, where's 0, 1? Here's 0, 1. Well, what I'm going to do is in that particular cell in your grid, it's just going to stick in the value 5. Okay? And you can use that like an integer anywhere else. You could use it like an integer or a single element of an array. Okay? The other thing that's kind of funky about this is that this two-dimensional array is really, well, the way you can think of it is it's an array of arrays. Right? It's an array, think of it this way, is an array that has 2 entries in it. And what is each one of those entries of the array? Well, really, every entry of the array, you can think of this as one cell, that whole thing. and this whole thing is another cell, and each entry of that first dimension of the array is just another array with 3 elements in it. Okay? So what that allows you to do is say something like matrix sub 0, and matrix sub 0, the type of this thing is an integer array, a single dimensional array. Because what is matrix sub 0? It's this whole line here. It's the first row of the entire matrix. And then if I specify something else, right, like I specify a column, that's how I get 0, 1. First I specify the row, then I specify the column. If I don't specify a column, this is referring to the whole row, which means it's just referring to a whole array. You can't. You have to refer to things in order. So there's no way to just pull out a column. So if you're feeling sort of like, oh, but in my Math 53 class, we do all this stuff with columns. Yeah. You just got to pick, in some sense, what's going to be your major ordering for this thing and have that one be first. So you could kind of think of it in your head that, oh, well, my first index is really my columns, and think of this thing as being the transpose and all that. But you got to just keep track of it in your head. Okay? Any questions about that? All right. So we can write a little code that makes use of this, just so you see a quickie example. And we could, for example, go through all of the elements of this grid and set their initial values to be 1. So we could have something like for int I equals 0, I is less than, and what you want I to be less than in the first index is 2, I plus plus, and then you're going to have some other for loop. Let's say this is for int j equals 0, j is less than 3 because that's the size of my second index, j plus plus, and then inside here I could just say something like matrix I sub j equals 1. And that would initialize all the cells in my grid to be 1. Okay? So any questions about that? Hopefully fairly straightforward kind of stuff. You can have as many dimensions of arrays as you want, sort of within reason, and within reason being how much memory your computer has, right? Because if you imagine, hey, I not only want a 2 by 3 matrix, I want a 2 by 3 by 100 matrix. So this becomes a 3-dimensional array. Right, so I basically have this grid repeated 100 times going forward. Suddenly you're using up a whole bunch of memory, right? So you want to be careful doing that. But if you want to do that, you would just add another, pair of brackets here, and you'd add another pair of brackets over here with 100, and now you would have a 3-dimensional array. So if you want to create, like your friend, the Rubik's Cube or something, which is 3 by 3 by 3, now you know how. Okay? And if you want to do real funky things with 4- and 5-dimensional objects or whatever, be my guest. Okay? But we're not going to use them a whole bunch in this class. So I might show you some examples of 2D stuff momentarily. But and most of the arrays we're going to deal with are just what we refer to as 1-dimensional arrays, right, which is just a list. All right, so any questions about multidimensional arrays? If you're feeling OK with multidimensional arrays, nod your head. Good times. All right. So moving on from the array, we can now go back to our friend that I briefly introduced last time. And now we can go into excruciating detail, our friend, the array list. Okay, and the array list, the way you can think about it is it's an array just kind of cooler. Okay? So the idea behind an array list is an array list, first of all, really is an object. And it's an object that's provided for you in the Java util package. We talked a little about this last time. I'm just repeating it just for good measure. So you import the java.util.star package to be able to get at the array list class. Okay? And the way you can think about an array list is it's really like an array, except it's an array that dynamically changes its size depending on how you add elements to it. So it can say, you can just say, hey, add another element to the end. And it will just go, hey, you know what? I'll just create an extra element at the end for you, and now your size is 1 greater. And so the way to think about it is in terms of effective and actual size that we talked about last time with regular arrays. You set up what the actual size is that's declared, and then your effective size is how much of it you're using. With an array list, think of it as the effective size and the actual size, at least stylistically, are exactly the same thing. Whenever you want to add another element to the end, its effective and actual size both grow. Okay? Now, underneath the hood, the implementation actually involves some stuff where the effective and actual size can be different, but that's all abstracted away for you. As far as you're concerned, effective and actual size are basically the same thing. Okay? And it provides some other functionality that's nice, and I'll show you that in just a moment. But this particular array list thing is called a template. And the reason why it's called template, I'll give you a little history of templates. I mentioned this briefly last time, but I will mention it again. Starting in Java, the book refers to it as Java 5.0. A lot of programmers will say Java 5.0. Some programmers will say Java 1.5. And what you have installed on your computer is either Java 1.5 or Java 1.6, which some programmers would say is either Java 5 or Java 6. which you would look at and say, hey, Maron, that makes no sense at all. Why is it like that? So I'll give you a little bit of history. Quick history lesson for the day. Many years ago, about 1995, there was this thing called Java 1.0. It came out, people were happy and went, oh, nice. Then Java 1.1 came out and people looked at that and said, yeah, nice. And then Java 1.2 came out and people said, nice. So when they said, nice, 1.2 in some people's mind was such a major change in the language Java that they started calling it Java 2.0. And at that point, when 1.3 comes out, you can't say, oh, well, that's 2.1, right? Because then it gets really confusing. So then when 1.3 came out, people called that Java 3.0. And 1.4 was 4.0. 1.5 became 5.0. 1.6 became 6.0. But in fact, the confusion still exists. So if you go and look in your system, most of you on your system, it'll actually have this 1.x number. Most programmers will actually refer to it by just the x as opposed to the 1.x. Don't be confused. They're really referring to the same thing. Okay? So what we're dealing with here in terms of array list as templates is Java 5.0 or later. So sometimes that's just written as 5.0 plus, which all of you should have because that's what you installed at the beginning of class. The book actually shows both the pre-5.0 and the post-5.0 version. We're just going to deal with the post-5.0 version because at this point the old version is just not worth worrying about. Okay? So what is this thing called a template that exists in Java 5.0 and later versions? Okay? What a template is it's basically a class that allows you to specialize it based on the type. What does that mean? Okay, so let me give you a few examples of what that actually means. What that means is when you see methods for this ArrayList class, and you'll see them listed in the book, you'll see something that looks like this. There's a method called add, and it returns a Boolean. And you're like, oh, that's all good and well. What kind of parameter does add take? And you'll see this funky thing that looks like this. Bracket T, bracket, element. And you look at that and you say, oh, Maron, you never told me about the bracket T, bracket type. What type is that? And the way you can think about it is this is a parameterized type. When you create an array list, you say, I'm going to create an array list of a particular type. So when you set up your array list, you create an array list object. And when you create that object, as you saw last time very briefly in angle brackets, which are actually less than and greater than signs, you specify a type like string. So you say array list string, and we call this thing, for example, slist, and we might create that to be a new array list. Again, we specify the type string, open paren, close paren, because you're actually calling the constructor, which takes no arguments. Okay? So you create this new array list, and this thing that you specify here, the type that you specify there, is what we refer to as the type for the template. You can think of the template as having all these holes in it. And the way those holes get filled in is they get filled in with whatever type you give it here. And those holes are specified by this bracket T bracket. The way you can think of this T is it's the type, that's why it's a T, that this template is what we refer to instantiated as. You create one of these templates of this type. So I create an array list of strings is the way programmers refer to it. Usually you can think of this as meaning of, and this as meaning nothing. So array list of string is how we would actually say it. And when you create an array list of string, you get an add method for this array list of strings that's now bracket T bracket is replaced by string. So the method that it actually provides for you is an add method that takes a string type. Okay? If I were to create an array list of G ovals, I would have an add method for that class that's element was a G oval. Okay? So creates for you, basically creates for you a whole class that has all the holes filled in with whatever type you specify here. Any questions about that? Kind of critical concept, new in Java 5.0. It's new, it's dynamic, it's cool, it's funky. People like it. Now you can too. All right? So let me show you some of the methods that you get with this array list kind of thing, and then we'll actually go into the details of using it. And you'll notice when we talk about the methods, this bracket T bracket thing will show up all over the place. And the way you want to think about that is this is just getting replaced with whatever type you instantiate your array list to be. So if we go to the computer real quick, dun dun dun, drum roll please, it's the methods of the array list. So what are the methods of the array list? Okay? First two methods are add. What add does is it takes in some element type of whatever type your array list is instantiated to be, right, the bracket T bracket, and it adds it to the end of the array list. And you might say, hey, Maron, why does it return a Boolean? And it always returns true for the Boolean. So why does it return a Boolean at all? And in about a week, it'll be clear why it always returns a Boolean. Okay? And why, in this case, it's always true. But as far as you're concerned, you don't really care about the return type. You're not going to do anything with it because it's always true. You're just going to say add, and even though it's returning something to you, you're not going to assign it to anything or care. It just adds an element to the end of the array list, which means the array list dynamically grows by 1, right? It's an array with dynamic size, so it just creates the space for you and adds the new element to the end. You can also add in a particular position, just like you could add in an array at a particular position. You can do that in an array list by specifying the index and the element that you want to enter at that index, and it will just put that element in at that index for you, and it's just kind of all abstracted in terms of how it does that. Okay? It's just growing its size as needed. Besides adding things, you can remove from the array list, right? Which is something that's funky. You didn't really think about removing from an array, right? An array, you could sort of say, yeah, read that value, and maybe I don't care about the value anymore, but you couldn't actually say, yeah, just get rid of that value completely, like get rid of the space associated with that value, okay? So when you say remove at a particular index, it actually removes that element and returns it to you from the array list. And similarly, you can remove a particular, you can either remove or you give it an index and say, give me back that particular element, or you can remove a particular element if it appears. So this returns a Boolean. So let's say you have an array list of strings, and one of your strings may be cs106a. And you're like, oh, cs106a, it was so near and dear to my heart until I had to take an earthquake, a midterm in the middle of an earthquake. Remove cs106a. And then you try to do this for everyone on campus. Well, some people have 106a, and if it appears, it'll return true and remove it from the array list. But some people don't. And it doesn't suddenly crash their program or whatever. When you come to that person and you call remove on cs106a, it just returns false to indicate, hey, cs106a wasn't in this array list. I didn't make any changes to the array list. And similarly, if you just get really angry or you decide, oh, I'm going to take some time off from Stanford, I want to just clear my array list of classes, you can call clear, which just removes everything in the array list. It just kind of resets it to be a blank array list. Okay? You can ask an array list for its size. Not particularly exciting, but very important to actually be able to do. Just returns how many elements are currently in the array list. Besides putting elements in an array list and removing them, it wouldn't be much fun if you couldn't actually get an element. So getting an element at a particular index returns the object at that specified index. It doesn't return it. It just essentially remove it from the array list. It just gives it back to you. So if there's an object or some element at position 1, okay, and you call get, it remains at position 1. If you call remove, it's actually removed from the array list. Okay? And then there's set. And so set, you can actually say, hey, at some particular location, I don't care what's there. Just slam this thing I'm going to give you. So what it does is you give it a particular index, and you give it some particular value, and it puts that value at that index. So you can say set at position 1, the string 106b, because now after you've taken 106a, you're maybe next quarter you're taking 106b. And it says that's great. And what it gives you back is the old value at that index. So it would give you back 106a if that was the old value that was there. Just in case you want to do sort of the quickie sleight of hand change, presto, change-o, stick something new in, get the old value out. You can do that if you want. That's just the way it is. Last but not least, couple things real quickly. You can get index of. This is kind of funky. This essentially does a search for you on the array list. So you give it some particular value. Like you could say, hey, is 106a actually in my array list? So you would pass it the string 106a, and it would return to you the index of the first occurrence of cs106a if it was in your array list, and -1 otherwise. It's just kind of like the index of operation that you did on strings before when you called it with like characters or substrings. It's the same thing here, except now you have a whole list of things, and that whole list of things can be any type that you want. Contain, same kind of thing, basically just returns a Boolean. You give it some value, and it says true or false. This value actually appeared in the list. And is empty, just returns true or false to let you know if the array list contains any elements at all. Okay? So fairly generic, basic functionality, and it's all kind of good and well, and we're happy. So let's use some of that and actually write a program that makes use of an array list together so we can see how some of this functionality actually looks, and then we'll try it out on the computer and try a few more advanced things with it. Okay? So here's our friend the run method. We got public void run. Inside here, we're going to create a new array list of strings. So I have array list of string. Ignore that part, although you need it for the syntax, but we just don't say it as programmers. We say array list of strings. My string list, I'm just calling it S list, is a new, very similar to what you saw there, array list that holds strings. And there's no parameters for the constructor, so I make sure to have the open paren, close paren, even though it looks kind of funky, you got to have it. So I just created one of these. And now what I'm going to do is just repeatedly read strings from the user until the user enters a blank line to indicate, hey, there's no more lines that I want to give you. And then I'm going to write them all out. Okay? So I have some while loop in here, and I'm going to do, my friend, the while true loop, right, the old loop and a half construct, where I'm going to have some string line that I'm going to read in from the user. So I'm just going to use read line, and to keep the prompt short, it'll just be question mark, and I'll just assume the user knows to enter a line there. I want to check to see if that line actually contains anything, so I check is the line dot equals to the empty string, quote, quote, and if it is, then I'm going to break, which means the user just gave me a blank line, so there's no more lines they want to enter. And if they gave me a line that is not equal to the empty string, then I actually got some valid line. I want to stick that string inside my array list at the end and tell my array list to just kind of grow in size. So I do that by just saying slist.add, and you'll notice the parameter that add's going to take up there is something of whatever the type of the array list is. So in this case, it's going to be a string, so I can do an add on line whose type is string, and I'm perfectly fine. And this will return to me true, but I don't care because I know it always returns true. Okay, so I'm just not even going to assign what it returns to any variable. And this will keep reading strings from the user until the user gives me a blank line to indicate that they're done. And then I'll write a little loop. So this is just the continuation of the program to actually print all those strings on the screen so you can see what that looks like. Okay, so I have a little for loop over here for I equals, forgot the int I. For int I equals 0. I is less than. I need to know how many strings were actually entered into my array list. Okay? Well, I can use my methods over there to figure that out with size. So I just say slist.size I++. And inside here, I'm just going to print line. And the line that I'm going to print is sequentially, I want to go through my array list and get strings one at a time at the given index. So how do I do that? I just say string list, and what's the method I use? Get. The single syllable gets candy. And so does everyone around. Mostly the MTC. Get I. So that will get the ith string. I got my parens lined up there, and that'll print everything out. So it just gets a bunch of lines to the user, prints out those lines on the screen. Okay? But notice I don't need to declare an initial size for the array list. I don't need to have it worry about, oh, is it big enough? Did I overwrite the end of it? Do I get the big, mean, evil exception going off the end of the array list? No, it just keeps expanding space as long as I need space. That's why it's so versatile to use. And when I'm done, I can just go ahead and say, hey, what's your size now? And then I can add more if I want. So let me show you a generalization of this program that we just wrote. So if we come back to our friend, all done with you, PowerPoint. Thanks for playing, and don't save. All right, so we come over to our friend Eclipse, and here's a simple array list example, oddly enough, named simple array list example.java. So what this is going to do is this is going to pass around the array list as a parameter, doing the same functionality, but I just want to show you what it looks like when we decompose the program a little bit and how we pass array lists as parameters. So I create an array list of strings here, right? Same syntax that I had before. I just called it list instead of slist. And I want to read in that list from the user. So I'm going to pass as a parameter the whole array list. The way I pass the whole array list is just by specifying the name of the parameter, which in this case is list. So I'm going to read a list from the user. So what does read list do? Here's the whole read list function. Now here's the funky thing. If we could get the computer, that would be extremely useful. The read list function, how do I pass an array list as a parameter? I just say array list and list. And you might look at this and say, oh, but Maron, you're not specifying what kind of array list it is. Is it an array list of strings, an array list of integers? The function or the method doesn't care. All it cares about is you're giving me an array list. And I'm going to assume you're going to do sort of the right thing with it in terms of putting stuff in and taking stuff out of the array list. But you're just giving me an array list. So you do not specify as a parameter the type that array list stores. It knows, because the actual object you pass underneath the hood knows, hey, I'm an array list of strings. So if you try to stick something in it that isn't a string, it'll get upset. But it just trusts you when you actually pass it as a parameter. And so here we say, while true, string item equals read line. So here I'm just calling it item instead of line. I read a line from the user. If that line happens to be equal to quote, quote, I'm done and I break out of the loop. Otherwise, what I'm going to do is add the item that was just read, which is the string, to the list. So it's exactly the same code I had here. I just have decomposed it out into a function. Now notice I don't return anything from this method. And the reason why I don't return anything from the method is an array list at the end of the day is an object. When I pass an object, what happens to changes I make to the object? They persist, right? It's an object. It's like the Mona Lisa that's being shipped around in the truck. If I go and slice the truck in half, I slice the Mona Lisa in half because I really have the real object. And so I don't need to return anything because any changes I make to this array list, because the array list itself is an object, those changes actually persist. And so whether or not you think of an array list as an object or as an array, in both cases, if I pass an array to a method or I pass an object to a method, in both cases the changes persist. So it doesn't matter how you think of array list. And if it's easier for you to think of it as just an array, think of it as an array and the changes persist. And if it's easier for you to think of an object, which is what it really is, then that's the changes persist as well. And the truth underneath the hood, be real quiet. Arrays, just the regular arrays, are objects too. Okay, just so you know. But you don't need to worry about that. All right, just think of them as this thing called an array. So that reads a list, and then after we read the list from the user and all these changes that we've made to list persist, I print out the array list. Okay, and all print out array list does, again, it gets the array list as a parameter, and it just says the list contains list.size elements, so it tells me how many elements are currently in the list, and then it does the little for loop that I just drew up on the board, going through all the elements from 0 up to size, actually size minus 1, and writing them all out on the screen. And I'm going to do this twice. So I'm going to read the list, print it out, and then I'm going to read to the same list just to show you that the list is going to continue to grow when I do that. So let me run this. I already compiled it. So it's asking for lines, cs106, just s106a. That's over in the psych department. cs106a, rocks, and that's the end. It says list contains 2 elements, cs106a and rocks. And I'm like, oh yeah, I forgot to add heavily. And now the list contains 4 elements. Because I continue to add stuff, it's that same list. It just continues to append on to the end. Okay? So any questions about that? It's not like you just add, and after you add and you stop adding, or it's just frozen. It's not frozen. You can just keep adding more stuff if you want. Okay? Any questions about that? Are we feeling okay about the array list? Now here's the funky thing. At this point you should be going, hey, array list, kind of cool. How come this whole time, Maron, you've been doing array list with strings? I thought, like, the simple type was like int. Why weren't we doing like array list of int? Any guesses? No guesses? No guesses. All right, I'll give you a hint. It's a popular science fiction TV show from the 70s. Actually 60s, I would imagine. 60s and 70s. I think it's actually 60s. Keep thinking, it'll get you closer. Here's the funky things about array lists. An array list as a template can only be instantiated, which means its type can only be specified to be object. So array lists hold objects. As we talked about in the past, int, double, boolean, and our friend the little char, always comes at the end, just kind of struggling along, are not objects. They're primitive types. So I, in fact, cannot have an array list of int. If I try to say array list bracket int bracket, I get an error because an int is not an object. So in order to get around that, remember a few lectures ago we talked about, hey, for every one of the primitive types, there's an equivalent class type. So these are the primitives and the equivalent class types, which are called wrapper classes because they kind of wrap around these. The wrapper classes are integer, all capitalized, full word, double capitalized, boolean capitalized, and then character all written out and capitalized, are the wrapper classes. So if I actually want to have an array list that holds integers, it can't hold ints. I need to create an array list that holds integers. It actually has to hold objects, so it has to hold instances of some class. Okay? Now, in the bad old days, was Java, pre-Java 5.0, this made array list really cumbersome to use. Because every time you had some integer somewhere, you said, hey, you know what? I have this thing called int x, and maybe its value, I set it originally to be 5, and now I want to stick this inside some array list of integers that I created somewhere, and I can't do that. So I need to actually go and create a new integer object and assign the value for that integer object to be what x is, and it just became a huge pain. So you actually need to do something like this. You need to say integer y equals new integer, and then give it the value x. Because what you needed to do was say create a new instance of the integer class, and its initial value you gave it as an int, and then it created this nice little box for you, which was the integer object, and inside the box there was this little space for the actual value, and it held the 5 in there. And that was a pain to have to do this every time you wanted to put some object into an array list of integers. And similarly, if you wanted to get something out, you had to do something equally cumbersome, which if I wanted to get the value out, so if I wanted to have some integer z here, and I wanted to say, hey, get the value of that integer, I can't just say z equals y. At least I couldn't in the bad old days. I needed to actually say y.int value and call a method on it. And then what this gave me back from that object y was its actual value as an integer. So it would give me back the 5 as an integer. Okay? All that changed in Java 5.0. So the process of essentially creating an object around a particular primitive, right? So we had our little primitive int 5 over here, and what this was basically doing was creating y to be an object around the 5. This process was called, or still is called, boxing. Because basically what you were doing was drawing another box around your value. And this process over here of going from the box that you had to getting the value out of the box, interestingly enough, was called unboxing. Because basically when you wanted to get the value out, you cared about the value inside, and essentially you wanted to erase the box that was around it. Okay? This whole boxing and unboxing happens for you automatically in Java 5.0 and later. Which means if I create an array list of integers, let me create an array list of integers over here, I can just add an int to it directly. So if I were to have array list, it still needs to hold objects of the integer class. So I still can't say array list of int. And I'll call this ilist equals new array list integer. Okay, so I create one of these things. Now I can say ilist dot add and give it x directly, where here I might have int x equals 5. And you would say, but Marilyn, you told me this array list can only store integer objects, and you're passing an int. You told me that doesn't work. Well, this is what Java 5.0 is doing for you automatically. It says, hey, this thing's expecting an integer, and you're giving me an int, which means you really need to box it up. It's kind of like, you finished eating your dinner, and you still have some food left, and you want to store that food somewhere. What do you need to do? It's got to go in a box. And before, you used to have to ask like the waiter or waitress to bring you a box, and they would create it in the back room somewhere, probably out of other food that wasn't eaten. And then you would get the box and you'd put your value in, you could finally go and store it at home. And now Java just says, hey, you know what? People were asking for the box so often. Yeah, if you need that food stored in a box, I'll just put the box on it for you. And then when you want to get it out over here, like you want to say int z equals ilist dot get the 0th element, before you would just get the box, right? Because that's all this thing is storing, are boxes that hold integers. Now I'll actually take the box off for you and let you eat the food automatically. Okay? So it does that for you automatically, which makes these things a lot more useful. And the thing to keep in mind is all of these wrapper classes are still immutable objects. They're immutable in the same sense strings are immutable. When you create one of these guys, like this guy, y has the value 5, its value is 5. You can't go back and say, hey, set its value now to be 6, because it does not have a method to set its value. It can get you its value by asking for its integer value, but there's no way to set its value. If you now want to create some new integer that's value is 6, you need to create a new integer and actually say, what's its value? It's y plus 1. Okay? Just in the same way with strings, you couldn't change a string in place. If you wanted to actually change the string, what you really need to do was create a new string that copied over all the characters from the old string that you cared about and potentially made some other changes. Okay? So the wrapper classes are immutable in the same way strings are immutable. Once you set their values, it does not change. If you want to make it look like it's really changing, what you do is you create a new one and you assign it to overwrite the value of the old one. Okay? So let me show you an example with that. And we'll use our same little code here, and this is going to be so much fun. All we're going to do is say, hey, you know what? Rather than having an array list of strings, I'm going to have an array list of integers. And you're going to say, but Marilyn, this is going to make your whole program blow up. Well, read list doesn't care what type of array list is getting passed in here. It's just getting passed an array list. I don't want to put strings in there, so I'm going to change my item to be an int, and I'll read an int from the user. And basically the way I'm going to stop is if that int is equal to 0, and add actually will just remain the same. And here's the coolest part of all. Print array list doesn't change at all, even though I just went from strings to integers. Why does it not change at all? Because this array list parameter here doesn't care what type you're passing in. The list contains the size method doesn't care what type is actually in the list. This list.size doesn't care what type is in the list. And when I get the element from the list, what I'm getting is an integer object. And when I go to print it out, it automatically gets unboxed for me to get turned into an integer and printed out. So even though I changed from an array list of strings to an array list of integers, because I never specify the type here, and that's just the way life is, that function will just work unchanged. Okay? So let me run this program again. Yes, go ahead and save and do all the happy things you need to do. 1, 2, 3. Oh, illegal numeric format, right? It wasn't a line. It wanted a 0. Now the list contains 3 elements, and then I'll add 4 and 5, and then give it a 0, and now the list contains 5 elements. Okay? Again, the beauty of object-oriented programming and the beauty of templates. Some things can just be reused even though you change the type, and you just need to be careful what you're actually storing and not storing. Okay? So any questions about that? Alrighty. Another quick example. When we talked about arrays, I told you, hey, you know what? You can have an array that contains like objects in it too. Like you can have an array of G objects or an array of G ovals or whatever you want. That's perfectly fine. And you can do the same thing with array lists. As a matter of fact, with array lists, you don't need to worry about all this boxing, unboxing stuff, because if you have an array list of, let's say, G ovals or G rects or whatever the case may be, those are already objects, so there's no boxing or unboxing that needs to go on. Okay? So if I, let's say, was going to have an array of G labels, I could say G label. Actually, let me show you this first of all in just the case of regular arrays, and then we'll move on. So I can have an array of labels. Okay? So here's labels, and I say something like new G label that has 4 items in it. Okay? And what I get here is 4 elements of my array that all start off null because none of them have been initialized. Okay? That's what I got in the array world. If in the array list world I create an array list of G labels, I would say something like array list that's going to store G label. And I'll call this my G list, or I'll call it my GL, equals new array list of G label, open paren, close paren. This creates for me an empty list of G label objects. If I now want to add G labels, I still need to create the actual underlying G label object and then add it to this array list. Much in the same way that with a regular list, when I created the array, all I got was just an array of nulls. So if I wanted to have the individual elements, I still needed to call a new on a G label for each one of the elements I wanted to create. Same kind of idea going on with array list. All I get is an empty list, and every time I want to add a new G label, I should have created that G label object already. Okay? So let me show you an example of this. With another funky program. We call it graphic numbers, or I call it graphic numbers. I just wrote it this morning. And all this thing is going to do is listen for the mouse. Okay? All the activity is going on when I click the mouse. So what's it going to do? What it's going to do when the mouse is clicked, well, before the mouse is clicked, I have some instance variable in here. The instance variable I have in here is this thing that I just showed you. I have an array list. It's going to be private, so it's going to be within my object. That's an array list called labels that holds G labels. So what I get when this line executes, when the program starts running, is I get an empty array list of G labels. There's no G labels in it. The way I'm going to add G labels is every time, this is the whole program, every time the user clicks the mouse, I'm going to create a new G label and add it to the list. Okay? So what I do when the user clicks the mouse is I'm going to create a new G label called lab, and the label or the text that's actually associated with this label is just the pound sign or the number sign, and then however many labels are currently in my list, which means at first it's going to be 0. So it's going to give me a 0, and the label is going to be number 0. And the next time it's going to be number 1. And the next time it's going to be number 2, etc. But first time it'll be number 0. I set the font on that label to be Courier 18, because like as the years are passing, my eyes are having problems, so I need the font to be big. And then here's the funky thing that I want to do. I want to say, you know what? Where am I going to put this on the screen? I always want to put the brand new label, like when it's born, in the same place on the screen. But the problem is if I put number 0 there, and then when I'm ready to put number 1, if I put it right on top of number 0, it's going to get real ugly, and it's going to be a mess, and it's like dogs and cats sleeping together, and the whole thing, it's not going to work out. So what am I going to do? I'm going to say, hey, why don't I take all the other numbers I had before and move them down one line so the new guy will always show up on top, and then when there's going to be a new one, everyone will move down and make room for that new one. It's kind of like a waterfall of numbers, just kind of like the movie The Matrix, right? It's kind of like the numbers will all just move down, the next number will take its spot. So how do I do that? Star Trek. Think Star Trek. All right, so I'm going to take all the existing labels that I've already put on the screen and move them down. How much am I going to move them down? I'm going to move them down in the y direction, the height of the label. So the reason why I first create the label without a location and set its size, or set the font, is because I want to know how big that label actually is and how much I need to move everyone else before I put this on there. So I say, label, get your height. Tell me how big you are so I can move everyone down that much space to put you in. And now I'm just going to have a for loop. And that for loop is going to go through my label list, which means it's going to go through all the existing label objects I have. I'm going to say, hey, in that label list, get the ith label and move it down by the amount dy. Okay? So this for loop goes through all of the objects that are in my list of labels and tells them to all move down. So wherever place they were on the screen before, they all move down one step, and that step is dy pixels. And after they've all moved down, they said, hey, hey, we made space for the new guy. New guy, come on, come on, come on. And the new guy runs over. He's like, oh, I'm part of the number group now. And so we add him to the campus, or the canvas. We add the label. We added the start x and the start y location, which is always the same. Start x and start y are just some constants that are given here. So the new guy always goes to the same place. Everyone else just moves down to make room for it. And I want to remember, hey, new guy, we're not just adding you to the screen. We've got to add you to the array list, too. If we don't add you to the array list, we're not going to be able to move you next time we need to move you when you're no longer the new guy. So this add is adding to the canvas. This add is being called on the labels array list. So it's adding this label object to the array list. So there's two adds we do. One puts it on the screen. One puts it in the array list that we keep track of. Any questions about this code? Let me just run this code so I can show you what's actually going on and how everyone just moves down for the little guy, okay? Which I realized is basically what happens to your life when you have a child. Basically, everything else in your life that you thought was important moves down, and the little guy really takes over. So here's graphic numbers, and it's just the most wonderful thing in the world. All right, there's 0. I clicked once. Now I'm going to click again. Oh, 1 comes in. Now I'm going to click again. That means 0's got to move down by dy. 1's got to move down by dy, and then 2 comes in. And if I keep clicking, everyone just keeps moving down, and the new guy always, or new woman I should say, or new it if we want to be gender neutral, just shows up in the same place. And then you can play games with your friends like first to 100, right? Yeah, because it's like 4 a.m. and you're like, no, no, first to 1,000. You're like, I got a paper to write tomorrow. How about first to 2,000? Yeah. It's just, and like number 0 is still there. It's just way off the screen, but it's still down there going, yeah, new guy, come on, I'm just moving for you, right? And it doesn't know it's not being displayed anymore. Okay? So any questions about that? Right? So you can have an array list that contains any kind of object. Now there's one last thing I just want to show you that's just fun and cool. Okay? And here's the thing that's fun and cool. The thing that's fun and cool is now that you've learned about all this stuff with arrays, and we're like, oh, you know, like you can have an array of like numbers, or you can have a matrix of numbers, and you kind of look at that and you're like, yeah, Maron, yeah, math, yeah, that's kind of fun, kind of, sort of. But you know what I really like? I like pictures. Can I do stuff with pictures and arrays? And you think for a while and you say, yeah, because if you couldn't, I wouldn't be asking you that question and setting you up for the fall. Sometimes I might, but not right now. Think about a picture, right? And by a picture, I mean a G image. What is a G image, really? A G image is basically made up of a bunch of pixels. And those pixels live in an array, basically. Actually, it's a grid. They live in a two-dimensional array, right? So if I have some G image that looks like a smiley face, maybe I have some pixels that look like that, and I just have some G image, and those are the individual pixels. And you look at that and you say, huh, that's kind of cool. Could I actually manipulate that grid of pixels? Yes, in fact, you can. And the value that's stored in each one of these elements of the G image, there's some pixel array, which is actually a two-dimensional array, and I'll show you how to manipulate it in just a second. There's an int that's stored in each one of these cells. And you might look at that and say, an int? Why an int? I thought like I could have all these colors. Well, it turns out, in fact, you can encode a whole bunch of different colors in a single int using something called RGB values, which stands for red, green, and blue. And if you ever look real closely on your TV screen, every little dot on your TV screen, unless you have like an LCD TV screen, if you look at the old school TV screens, they're really made up of a little green dot, a little blue dot, and a little red dot. And the way you get different colors is how intense each one of those three things is. So this single integer actually encodes all three of these values using an encoding scheme that's actually described in the book. It's not worth going into all the details. You don't need to worry about it. But all you need to know is that you can get that red, green, and blue value out of this single integer. Okay? So if you can do that, what kind of stuff can you actually do with your program? You can take an image, let's say a color image, and turn it black and white. And you say, how do you do that, Meron? So let me show you. We're going to read a G image from a file. So this is just the standard G image stuff you've seen before. We're going to create a new image that's going to read this file called milkmaid.gif, which is basically just a little picture you'll see in just a second of a little milkmaid. And then we're going to create a grayscale image version of it. And then we're going to display both the regular image and the grayscale image at sort of twice their size. We're going to scale them by 2 because it's actually a small image to begin with. So we'll scale them just so you can see it more closely. And we'll try to show them side by side to each other. So I just put in some parameters to make them side by side. How do I create the grayscale version? What I do is I'm going to pass that G image as a parameter called image to a method called create grayscale image, which we're just going to write together, or I'm just going to show you here. What I can do from a G image is ask it for its pixel array. That thing over there, it's a grid. It's a two-dimensional array of integers. So what I get back in this parameter or in this value that I'm going to call array is it's basically just a two-dimensional array of integers. And I'm getting a copy of all of the pixel values of that image. How do I figure out how high the image is? I can ask that array for its length. Because remember, a two-dimensional array is an array of an arrays, which means that the array itself, or this thing called image, right, is basically an array that contains one row per element. So what's the height? It's the number of rows I have. So if you ask the main array itself, how many elements do you have? It tells you how many rows it has. That's the height of the image. So I get that from array.length. How wide is the image? It's how many columns are in one row. So if I say, hey, I can pick any row I want, but I'm just going to pick the first row because I don't know how many rows there are, and I don't want to pick some row that doesn't exist. So I say, hey, first row, you're array sub 0. What's your length? And it says, hey, I'm 40 pixels across. And then you know what the width of the image is, too. Now, once I have that, here's the funky thing. I'm going to have this double for loop that you saw before when I was going through a grid, right? So I have some index i and some index j. I'm going to set my individual pixel value to be the element at the array I sub j. So I'm going to pull out each one of these individual pixels as an integer one at a time. And there are these three methods in the G that are provided for you as static methods of the G image class called getRed, getBlue, and getGreen. And they get the corresponding red, green, and blue values that are encoded inside this single integer. And they return them to you as integers. So what you get are these little intensity values for the red, green, and blue. And based on red, green, and blue, there's these wonderful folks, the National TV Standards Consortium, something like that, NCSC, who said, hey, in order to go from a color to a black and white, you want to consider how luminous the image is. And luminosity depends on the color. So it's about 0.3 times the red. The green's a lot brighter, so it's almost 0.6 times the green. And blue we consider really dark, so it's about 0.1 times the blue. And these are just numbers that got pulled out of the air by this consortium. But that's how they determine what the luminosity or how bright something is relative to its color. Funky, but someone does it. And then we just round that value to an integer because we're returning an integer, and that's what we return. And we say, hey, that's great. You gave me that luminosity. I'm going to set that same luminosity value for the R, G, and B images. If you set the R, G, and B values to all have the same value, what you get is a grayscale. Because all the color blends out, and essentially you get something that varies from completely white to completely black, depending on how intense you've given those RGB values. And I store that back in this array. And at the very end, I'm going to create a new G image out of that array and return it. So let me just run this for you in our last -2 minutes together so you can actually see it. Anyone want to take a final guess as to what I am? Very close. I'm almost Spock. I'm Mirror Spock. Yeah, also known as Evil Spock. And it's because the whole costume is all around the goatee. Like my wife saw the goatee, she's like, you're Evil Spock. And so our son is actually Spock. So when we sit next to each other, he's like small Spock, he's about this big, and I'm Evil Spock. Yeah, it's so cute if you're kind of geeky like me. All right, so here's the original Milkmaid image, and here's that same image, and you just created the grayscale of it. So just one last thing, if you shut the camera off, because now we're going to get something that's, if you actually want to see it.